Let's look at an example now that isn't linear. So we're going to go back to World of Warcraft, and we're going to look at at the total XP it takes to reach the next level. So if you're level 1, how many XP does it take to reach level 2? Well, the answer there is 400, and so on. So I have that data in a spreadsheet, but you can see right away that from the graph that this is going to be nonlinear. You can see that curvature there in that picture, right? But let's investigate the data further just to see what happens with this idea of slope if we try to impose the idea of slope on this nonlinear data. Here's the data. So we see level 1, to get to the next level, it's 400 experience points, then 880 to the next, and so on and so forth, right? And we know it's not linear, but let's look at the rise over the run nonetheless. Right? So we're going to make a column for the rise and a column for the run, and then we'll divide them and get the slope. Of course, the runs are all going to be 1, but well, we'll do it anyways. As it makes sense, as I mentioned before, it doesn't make sense to start in that first row, so we'll go to the next row, right? As we've had in the past when we're looking at change. Oops, I forgot the equal sign. There we go. So I'm going to generate the rise. Let's go all the way down. These are all the levels up to level 59, what it takes to get to level 60. So you see all these rises are changing. Let's look at the run. Oops. I created a logical statement instead of an operation. So no surprise there. They're all 1, right? Because we're incrementing by 1. But just to, so for each of these, the run is 1, the rise is 480. Now let's calculate rise over run. C3 divided by 3. And of course, no real surprises here. But the important thing is that this slope, the rise over the run, is not constant. Right? In fact, it appears to be growing. Well, what does that mean? Well, if you take a look at this graph, notice just how it's getting steeper and steeper and steeper. The total number of XP you need to get to the next level is growing. It's not constant. We can actually make a graph of the slopes. Let's do that. So I'm going to insert. Look at this graph. This is the graph of all the slopes. So this tells you how many additional XP it takes to get to the next level as you move on, right? So if you look at this, we can see the slope certainly is growing, right? And we notice something kind of funny happens here, right? And if you go in and you dig into the back end, what they're doing with their experience points is in these middle levels, they're building these kind of enhancement factors to make things a little bit more difficult, and then some other factors to correct them in the opposite direction. So this is a little weird, but otherwise the slope is kind of rising fairly steadily. Right? But it's important to remember what that slope, what this graph represents. This graph is the slope, which is the change in how many additional XP you need to go from one level to the next. It's the change, not the number of XP. You don't need 6,000 XP to get to level 57. You need 160,000. But between levels 56 and 57, you need an additional 6,000, and that's the slope. So the slope is not constant, but we could analyze the slope as if it were its own function. We're not going to go that far, but that's exactly the kind of thing you would do in calculus. Finally, there's one other thing I want to show you. What do the formulas look like for something that's nonlinear? Because in the next section, not in the next video, but in the next section, we're going to work on using data to get our formulas for y equals mx plus b. But if I click on the Show Formulas tab, take a look. These are World of Warcraft's own formulas. We've got 40 times the level squared plus 360 times the level. And that's the case up to level 11. Then when you get to level 11, it gets even more complicated. Negative 0.4 times the level cubed plus 40.4 times the level squared plus 396 times the level. And then because there's weird things going on in these middle levels, I just typed in the values. But then for the upper levels, you can see you've also got something goofy going on. So you've got these other kinds of functions occurring. They don't look, the formulas don't look at all like y equals mx plus b. And that's exactly, and you won't see y equals mx plus b unless you have a linear function. So anyhow, this is an example of something that's nonlinear. Here are some ways you might notice it. The curved graph, the non-constant slope, or a formula that doesn't look like y equals mx plus b. In the next video, we're going to return to linearity, and we're going to talk about how to interpret the slope.